get 125 to 5 cubed, and then the 5 stays a 5 to the 2x minus 1, and then we get 5 squared to the x minus 3 equals 125, so that's 5 cubed to the 2x minus 1. I thought it was a ghost, personally, is what I thought it sounded. Okay, so what do? Make sure we're paying attention. Everyone's paying attention. You're not on your phones because I'm not doing this for my own welfare. I'm good at these. So we have we have to get the common base or we can't put them together, right? So when we have common base and we multiply, we actually add. So we're going to get 5 to the 2x and then 3 minus 1. So 3 plus negative 1 is plus 2. Over 5 to the 2x minus 6, do not forget to distribute, equals 5 to the 3x, that's not a 3, 6x, oh, good, pick again, 6x minus 3. Okay, what do we do on that left side now that we have division? Minus. We're in a minus. So you reacted like someone just threw fire at you, but you just dropped the calculator. So we're going to get 5, and then 2x minus 2x, what happens to my x? It's gone. 2 minus a minus 6. 2 minus a minus 6. 8. Equals 5 to the 6x minus 3. Remember, you're not adding, you're subtracting. So it's 2 minus a minus 6, which is actually 2 plus 6, which is 8. Because when you have the same base, you subtract exponents. So 2x minus 2x gone. 2 minus a negative 6 is 2 plus 6, which is actually 8. Now that we have the same base, 5 to the number, 5 to the number. So what happens is, at this point, a lot of the time on tests, people will drop the 5s off and just go 2x plus 2 over 2x minus 6, which you cannot do. The only time you can drop the bases off and make them go away is if you have a base to an exponent equals base to an exponent. So only once we got to this last step where we're at, can we drop the bases off. So now, because I have 5 to something equals 5 to something, these powers have to be the same, but it's only because I have single bases down here. So now I'm going to go 8 equals 6x minus 3, add 3, and I get 11 equals 6x, divide by 6, and x equals 11 over 6. Now, you can type the whole thing into your calculator. So if you have the fraction button, you're going to go alpha y equals enter and type this into y1 and this into y2 and find out where they intersect, and it should be the same answer. Everyone's doing that. Yeah?
How did you get 2x plus 2?
2x plus 2.
Well, 5 over 5.
Oh, when you put these together, you have to add them, same base. So we go 2x and then 3 plus negative 1. Yeah. So we're going to do y1, y2. If you have the older calculators, you're going to have to put the whole numerator in a bracket and the whole denominator in a bracket as well. So everyone's typing it in and then doing second trace 5, math entry. So, what's the first thing I have to do here?
Get y by itself.
Get y by itself and
Same base.
same base. I cannot compare these until they have the same base. So the original is 3 to the x. So I have to get this one to also be 3. How can I make a third be 3? 3 to the negative 1. So I can move the 3 over. But I'm going to do this first. So I'm going to go 3 to the negative 1. And I don't need to distribute it. If you distribute that negative 1 in, your accounts are doing something, because you're going to have to take it right back out again, because you need to have a positive 1 in front of your x, right? So just write negative 1 and leave the rest in brackets. And then at the back, I have a plus 3. Okay? So my transformations. I have a no I don't. I do not have any stretches. I have no number in front, no number in front. But I do have a reflection. Oh, great. Yeah, so this is the only one you can write together. You can say a reflection in the x and y axis. Then T. You have horizontal translation. You can go horizontal or vertical first, it doesn't matter. Horizontal translation, 3 left. And a vertical translation, I should say 3 units. Translation, 3 units up. For mapping, they're both going to be negative. And then I need to move it 3 left, so I'm going to minus 3, 3 up, plus 3. The asymptote, what kind of asymptote do I have on an exponential graph? Horizontal. It's normally on the x-axis, right? What's the only thing that moves it off the x-axis? Vertical translation. So your vertical translation is actually your horizontal asymptote, correct? We went over that yesterday. So the horizontal asymptote is y equals 3 because I moved 3 up and it used to be at 0. D is my range and my domain. My domain is easy because unless it's a word problem, what's the domain of an exponential? X is an element of the real. Or negative infinity to positive infinity in interval notation. Set notation is squiggly brackets. My range. What affects my range? The stuff that affects my y's, correct? So the front number and the back number. If the front number is negative, what happens to my range? It's a less than sign. It's never equal to. Is there a negative in front? Yes. So my range, y such that y is less than 3, y is now in the reals, or in interval notation, negative infinity to 3. Okay, then open some paper. We're going to start your next notes. We're in print, we're ready. So we're converting from logs to exponential and exponentials to logs. Because we weren't able to solve our word problems by anything but our calculator because we didn't know how to solve when there's an exponent up top and we can't do common base, right? The only way we've learned to solve an exponential currently is common base. So we're going to go converting from exponential to log. Double-headed arrow because we're going to do bold. Okay, so how we are going to convert, let's just look at a basic exponential function, a basic parent exponential function. So say we have y equals a b to the x. That's our basic parent function. We agree? And I told you you always have to do what if you have the final and the initial, which technically we have right now. You're going to have to divide it, correct? So we have to divide this a over. And I'm showing this first because people do this wrong all the time. So it's y divided by a equals b to the x. We agree? So that's what I told you we have to do every single time when we have that coefficient. We agree? Now the conversion of exponential to logs has you can only have 3 pieces. So that's why we have to divide that a over. If we don't divide that a over, we have 1, 2, 3, 4 spots to fill, correct? And we can only have 3. So I'll show you the conversion between exponential and log. So if we have y equals b to the x, that's the form exponential has to be in. There has to only have 3 pieces of information in order to convert to a log. Okay? If you remember this method, you will get it right every single time. So, this is what I need you to see. The base of my exponent, this is the base, correct? The base is what the exponent is at the base, and then the exponent is raised to the power of, right? So the base of my exponent becomes the base of my logarithm. If you remember that, you will get every single one of these questions right. The base of my exponent becomes the base of my logarithm. So we're going to write log base b. Do you see that? Base of the log, base of the exponent. They're the same. Okay? This is the only other thing you need to remember. Who is friends? She's having a rough go today. She's just trying to scare you the whole class. Okay. So, who is friends in exponential does not state friends in logs. So currently, who is friends right now? Who's together? B and X. They will not be side by side in a log. So what's going to be beside my log then if the X is currently beside B? What's the one that's not with it? Y. So I'm going to put a Y here. And then it's going to always equal what's left over. What's left over? X. And I just got the exponent to drop down, didn't I? And now I'd be able to solve it. I got the exponent to drop down. Do we agree? Okay. So, let's look. You guys are killing me. He's just because it says log. It's just really dry humor. Really dry humor. It's because you didn't catch it because it was very dry. Okay. So let's look at, guys, quiet please. So we are going to look at, we're going to solve our filled in word problems. So I'm not making you fill in the word problem right now. I'm going to give you a filled in word problem and make you solve for the time. Okay? So an increase, we'll start with a doubling, tripling, half-life one. Let's do that first. So say we have 1,000 equals 200 to the t over 20. This is a doubling word problem, correct? How do I know it's a doubling word problem? Because there's a 2. We agree? Now, I told you the only way we could solve these is if we could do common base. And if we couldn't do common base, we couldn't algebraically solve them. We had to use y1, y2. Right? But we can now algebraically solve them because we can convert to a log. So, it doesn't matter that we're converting to a log right now. What was the first step I told you always had to do when you had the final and you had the initial? You have to divide that 200 over. So we have 5 equals 2 to the t divided by 20. And now I would have to y1, y2 because I couldn't make common base. We agree? But if I ask you to solve it algebraically and you can't make common base and you need that exponent to get down, because right now that exponent's up there and I don't know how to solve it with the exponent up there. Okay? But I do know that if I convert it to a log, the exponent pops down and I'm done. It always gets equal to the exponent when you convert it to a log. That's the cool part. It equals the exponent. So, at this point I can't solve it, but I will be able to solve it using a log. So what did I tell you is the important part? The important part is making the base be the base. The base of the exponent be the base of the log. We agree? So I'm going to get log base 2. What is going to go beside it? 5, because what's friends with it currently? 5. The t over 20 is currently friends with it, right? And I told you that when you convert it to a log, it actually gets equal to the exponent, right? That's how the exponent pops down. It's going to equal the exponent every single time. But technically, the other way you can do it is, hey, what's friends to the currently isn't. So it's going to be a 5 beside the log. This is a subscript, this 2. And then it's going to equal 2 over t over 20. How would I get that 20 by itself?
The 20 by itself.
The t by itself, which is how you spell 20. Yes. Multiply by 20. So we put the 20 in front. Okay. I'm going to show everyone how you can type this in no matter what calculator you have. And then if you have the newer ones, I'm going to show you how you can type it in easier. Okay. If you have the TI-83s, you're going to have to do it this way. If you have some of the TI-84s, you're going to have to do it this way. But paying attention. Log base 2 of 5. The only button that you have right now, when you press that log button, you see there's a log button, it's 3 up from the on button. You see it? If you press that log button, it is log base 10. Okay? It's 3 up from on. It's log base 10. When there's no base, it's base 10. If I want to type this in, it's actually on your formula sheet. It tells you if you have log base B of C, you can go log base A of C, log base A of B, A being base 10. Basically, if you have this, the way you can type it into your calculator is if you do this. Watching? You add a log to the bottom. So you're going to go, if you have your other calculators, you're going to go log 5 divided by log 2, hit enter, and then times by 20. Everyone's calculators can do it this way. So we go log 5 divided by log 2, the base goes on the bottom, times 20. And I get 46.44. Yeah. If you have the new calculators, if you have the calculators with the exponent pops up, you don't ever have to do it this way. You can do it in a way where it just looks like that. So if you have the new if you have the TI-83s, don't even try this. If you have any other calculator, try this. The TI-83s, you are going to have to do it this way every single time. So Sean, you're going to have to do it that way. You're not going to have another option.
I already did all those numbers difference for fun.
Okay. So we're going to go, ready? Paying attention?
Yeah.
We're going to go 20, because we're going to make it look exactly like what I have there. I have 20, and then it's log base 2 of 5. We agree?
Yeah.
So you're going to go math, and you're going to arrow up to get to the bottom faster. And there's a log base button. You hit enter, and then you just type it in the way it looks.
Oh, my Lord.
Same answer. So the log base button is nicer, but it's not essential. Because you don't have that button. Yeah? So now, yeah, because you're picking A. It's the same thing. If you go math, arrow up, same amount of buttons. Yeah, because you're just picking alpha A off the list. Yeah.
No, you didn't.
You can't use the one I just did. So you're going to go, shh, quiet please. You're going to press log, and then 5, close bracket, divided by log 2,
Oh, no, I did.
and then times 20.
I was putting it in the.
Okay. Okay, so we get 46.44. Either way we do this, we get 46.44. What is T in the doubling formula? What does T represent? Time to reach the final. Time to reach final. The bottom is how fast it takes, how many, like, so if it's in minutes, let's say, this 20 down here means it doubles every 20 minutes, correct? Every 20 minutes it's doubling, it's doubling, it's doubling. Now, the top T says how long it takes to reach that 1,000. How long does it take? 46.44 minutes, which makes sense. Because at 20, it's going to double to 4. Another 20, it's going to double to 800, and then a little bit more, it'll be past 1,000. So it's going to take 46, it'll take twice the doubling period, right? A little more. So it makes sense. Okay, we're going to try a different one. What if I give you this?
You tell our smart board meeting to
It just moved on. Okay. B. Bless you. Okay. Quiet, please. What formula is this? Compound interest formula. Quiet, please. You're going to tell me what the heck this stuff represents. What's the 2,000 in the compound interest formula? The final. What I walk into the bank with? 1,500. What's this 1 represent? 100. It's just part of the formula, right? It's 100% in decimal form. What's a 0.06? 6% interest per year, per annum, right? What is this 2? That's how many times it compounds. So this would be a semi-annually. It's twice a year. And then this is the number of years times 2. So I'm making you find the number of years it's going to take to get from 1,500 to 2,000 at 6% interest per annum, semi-annually compounded. Right? That's what this is. I just filled it in for you. So let's go through this and actually solve it without y1, y2. So the first thing I have to do when I have my final and my initial is to what? Divide. So I'm going to divide the 1,500 over. And when I reduce that, I'm going to get 4 over 3 equals, now 0.06 divided by 2 is 0.03 plus 1 is 1.03 to the 2n. Do I currently have 3 pieces of information? Yes, and I can only convert from exponential to logs if I have 3 pieces of information. If I have more, I need to do something to get less. So, I would y1, y2, but now I can solve algebraically. So I notice I'm going to, if I need to get the exponent to pop down, I have to convert to a log every single time. If I can do common base, that's the only way I don't have to convert. I can't make 4/3 1.03. I do not know how to do that. So I'm going to convert to a log to get that exponent to come down. We agree? So it's going to be log base what? Yeah, the base of my exponent becomes the base of my log, 1.03. Now what's friends currently? 2n. So what's going to go beside my log? 4/3. Now I put in brackets my calculator, it's a fraction. And then it's going to equal the exponent always. That's the point of converting it to a log, is to get the exponent down so we can actually solve it with real math like we've learned in the past. Right? How do I get n by itself? Divide by 2. Every single person is using their calculator in whatever way they need to get it. Now, if you have the older calculators, you're going to have to go log 4/3 divided by log 1.03, hit enter, then divide it by 2. Try it out. What do you guys get? Here's whole number.
4. Never. Oh, I can't count it. 5. 4.9. 4. I said 5.
Not what I got. I get 20.
How do you get that? Putting everything in brackets, divide by 2.
I went log 1.03 and 4/3 beside it, hit enter, and divided by 2.
That's what I did too, and I got like 4.87.
Why is mine coming out? No, it's the calculator. Why is it coming out like that? Calculator's lying to me. I already used my calculator on my board. Oh. I timed. That's super helpful. That's divided by 2. Okay, we're at 4.8, so it'll be 5 years.
Was I correct or was I incorrect?
You were correct. There we go. So it's 5 years. It would take for this to go $1,500 to $2,000 and make $500 interest, right? Okay, so we can solve all of these now algebraically. We agree? Okay, what if I give you this now, though? Nothing crazy. Don't freak out. Say I give you 2 log 7 x plus 3 equals 5. So we convert from exponential to logs when the variable's in the exponent. We agree? When the variable's in the exponent, we convert to a log. Every single time, that's how we get the x down. We agree? We convert from a log to exponential every single time your variable's beside the log or in the base. So, I'm going to write that down. Convert from log to exponential when the variable is in the base or beside the log. Where's the variable currently? Is it in the base or beside the log? Yeah, it's beside the log. So I'm going to have to convert to exponential. Now, we talked about converting from exponential to log. I could only have 3 pieces. We agree? Well, conversely, if I want to convert from log to exponential, I can only have 3 pieces. Currently, how many pieces do I have? 1, 2, 3. I have 4. Correct? So what could I do? Yeah. Divide the 2. So if I divide by 2 here, divide by 2 here, I'm going to have log base 7 of x plus 3 equals 5 over 2. And now I can actually convert. What was our rule? The base of our exponent is the base of our log, correct? So now conversely, the base of our log is the base of our exponent. So this 7 is the base of my exponent. In order for it to be a base of an exponent, it needs a what? An exponent, correct? If it's just 7, it's not a base of an exponent, it's just 7. So it needs an exponent in order for it to be a base. So it's a base of my log, it's a base of my exponent. What's its exponent going to be? What's its exponent going to be? 5 over 2. Because what's friends doesn't stay friends, right? What's friends doesn't stay friends. What's currently friends? And the 7 and the x plus 3. Also remember, when we converted to exponential, whatever it equaled was the exponent, correct? So now if I'm working backwards, whatever it equals is going to be the exponent. It's the same thing. And then what does it equal? What friend it was. So it equals x plus 3. So I'm just going to subtract 3. And I get 7 to the 5 halves, which you have to put in brackets if your exponent doesn't pop up, minus 3 equals x. Everyone's typing it in. So I get x equals 126.64. Now, we can check this because it's a solve. Whenever it's a solve, we can y1, y2 the original and find out where they intersect every single time. The problem is my answer is 126. So if your standard window, if your x max is at 10, are you finding it? No, your x max always has to be bigger than the answer. So that's a really great way to check, because you have the answer, you know you need to make your x max bigger. So we're going to practice typing it in. Our y1 is going to be 2 log base 7 of x plus 3. And our y2 is going to be 5. We don't put it in as any other way. Just put it in the way we had it. And I know my x needs to be 126, so my x max is going to have to be bigger than that. So we can make our x max be 130, let's say. The rest can all stay the same. It's your x max that needs to be big enough to see it. Yeah?
Can you do the subscript for the second one? For your second seven?
No, we went over that. Remember, you do log x plus 3 divided by log 7. Right? The only way you can type it into your calculator log base is to write the whole log top divided by log 7.
Oh, okay.
Yeah. So if you have the older calculators, you're going to have to go to log x plus 3. I guess I should put it in brackets. Log x plus 3 divided by log 7. And then 5. And then your window, your x max has to be 130. So second trace 5, enter, 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 and I get 126.64, same answer. If you have the new calculators, I would never choose that option. I would go to math, log base, and then go 7 and x plus 3. Second trace 5, you get the same thing. Same answer, right? Just depending on what calculator you have the way you type it. Okay. Here's when you're going to try. Is it D? Yeah. What's the first thing I'm going to have to do? Divide the 3 over. Divide the 3 over, then convert. Try. Oops. I don't think, did I not record that? I don't even know. Anyways, the homework is in chapter 8. Okay, it's page 412. Numbers 1 and 2. That's it.
Is our homework stuff we do Friday?
Yeah.
Oh, it's too much.
If you have something like, the first one I think is 12 plus log x equals, was it 15?
Yeah.
So when the log doesn't have a base, when there is no base, every single time there's no base, write 10. Because the most common log used in the world in word problems is log base 10. So they allowed the log, every single time you're pressing log, it actually is base 10 every single time. So if we wanted a different base, that's when we have to go log 7 divided by log 2, if it wasn't a base 10. Okay? So whenever there isn't a base on it, write 10, because that is what the base is. So then when I move my 12 over, I get log base 10 of x equals 3, and now I can convert 10 to the 3 equals x equals 1,000. So when there is no base, your base is 10. So if there's no little number, no little subscript on your log, every single time just go write a 10 right away, because you're going to need it usually. And if you don't have it, you sit there and stare at it for a while.